All right, I'd like to walk through the weather lesson 3 information for you. The information tab for weather lesson 3 tells us that it's called the perfect storm. A lesson discovery question is, how do air masses interact to cause snowstorms? The learning performances for you. Students will identify and organize relevant weather data to analyze storm characteristics. Students will develop a model to describe how snowstorms develop from interacting air masses. And third, students will develop a model to describe how air mass interaction snowstorms create different weather scenarios across Michigan. Lesson introduction. In lesson 2, students discovered that large bodies of water can produce snowfall in the winter when prevailing winds blow a cold air mass over a warmer lake towards the land. They generated a lake effect snow model in the uncover and share. In this lesson, students organized data from a major storm event in 2009 to uncover that when two air masses with different properties interact, storms can occur along the interaction boundary. In the Check Your Progress, students complete a three-dimensional embedded assessment by developing a model and answering questions related to inflating a bike tire context. Snowstorms can be caused by areas of low pressure which develop when two different air masses interact along their boundary called a front. When two air masses collide, the less dense air is pushed upwards. This upward flow causes low pressure in the atmosphere near Earth's surface. Surrounding air from both air masses flows toward the low pressure, and in the northern hemisphere, the Coriolis effect causes this flow to circle counterclockwise. As air in the storm rises, it cools and condenses into clouds and causes precipitation. The effects of the storm are focused around the low pressure system, so precipitation occurs along the front. On the cold side of the front, the precipitation falls as snow. On the warm side of the front, it falls as rain. In the United States, storms are generally transported from west to east by the jet stream, which can also shift storms to the north and south. Okay, let's take a look at the instructions for the anchor phase. The anchoring experience, students have just seen how lake effect snowstorms impact regions around the Great Lakes and should influence snow day policy. But aren't there other types of snowstorms? Students are introduced to a different atmospheric mechanism that can cause massive storms throughout the United States, especially in the winter. Students encounter a weather report warning residents on the eastern third of the U.S. about a major weather event that impacted millions of people in 2009. Under student steps, you're going to watch a video, and I have the link here. I believe I also have the link attached at the bottom. Note, you can stop the video after minute 2:27 because after this point the meteorologist talks about forecast models. Those of you who are working on paper packets, I've included an article if you don't have access to the video. And then at the bottom there are 3 questions. I made this an editable document so you can answer them right there, or you can attach another document. All right, moving on to uncover. I'm not going to read the phase summary, just let's take a look at the student steps. You're going to read 3 accounts of a storm and organize your observations on the organizer table in your interactions guide. You're also going to need the Uncover Student Forecast document. Those are attached at the bottom. Students will analyze the storm impact composite image in their guides and identify patterns of the precipitation effects over the 3 days of the storm. Students use their current understanding to develop an initial model of how two interacting air masses can develop a storm. Students answer questions about the processes and the resulting weather patterns in their guides. So our student forecast is a single page document that shows a color image of the weather forecast. There's two, so if I were doing this in class, I print them in color and cut them in half. So you only need one of those. The student interactions. Let me get this to load here. Several parts. There's an introduction. Um, Part one directions, there are accounts of Dallas, Nashville, and Pittsburgh. And then there's a graphic organizer for you to fill in there. Part two, um, you're going to use that forecast image to make a model here. And I did include instructions for those of you who were confused by it. I included instructions. There's a short video for inserting a text box to make this model. Part three, and then there are several questions about the model that you made. All right, that takes us up to check your progress. Instructions in here are pretty short as well. Students to consider the phenomenon of pumping air into a bicycle tire and then reopening the valve. They relate this phenomenon to how air pressure is relevant to weather patterns by considering how differences in air pressure can cause winds. And then the students individually answer the embedded assessment questions. Those assessment questions would be on the attached editable Word document. Starts with a picture of a air pump and a bicycle tire, and there are several parts to this. I'm not going to read through them all. There's not very many questions for each part, but there are several parts that ask you to explore or describe your understanding. There are several attached articles as well that will help you to sort out or to gain more understanding. Okay, so that wraps it up for lesson 3.